So naming acids, I've covered this first couple of slides already, but let's go over it again because it's been a few days. So acids are molecular compounds, but when they dissolve in water, they form ions. And so we can use those ions to predict some of their formulas. The way we recognize an acid in Chem 3A is that hydrogen is the first element in the formula. So it's only an acid if the first element is H. If it's got hydrogen somewhere else, that doesn't make it an acid. The hydrogen has to be first. In the name of an acid is the word acid. So if it's something else, doesn't have the word acid in it, it's not an acid. Two kinds of acids. Binary acids, those have hydrogen and a nonmetal. Oxyacids have hydrogen, a nonmetal, and oxygen. So oxyacids contain oxygen. If it doesn't have oxygen in it, it's not an oxyacid. So naming binary acids, this is the pattern. We use the prefix hydro, and we look at the name of that nonmetal, and we change the ending of its name to ic. So fluorine would become fluoric. Bromine would become bromic. And then the word acid afterwards. So HCl, this is a binary acid. It starts with H. There's no oxygen. We take chlorine, and that becomes chloric. We put the prefix hydro in front, hydrochloric acid. HBr, hydrobromic acid. And then we did these examples. I'd just like to point out, why is there two hydrogens here in this one? Well, when this dissolves in water, and that's what AQ means, dissolved in water, it forms ions. And so you're going to have hydrogen ions, and you're going to have selenium ions. And what charge does a selenium ion have? It's on the periodic table. -2. Okay? So a 2- charge with a hydrogen ion, we're going to need two hydrogen ions to balance the charge. Acids are neutral compounds. The charges have to add up to 0. So that's why in this formula it's H2SE instead of just HSE. And this would be called hydroselenic acid. Binary acids all start with the prefix hydro, and then we take selenium, and we change the ending to ic, and then we add the word acid. Hydroselenic acid. Questions? I see some frowns. Oxyacids contain oxygen. We can think of the oxyacids as containing oxyanions. And we find these in the table of polyatomic anions, or polyatomic ions. If we look at HNO3, we should recognize this as an acid because it starts with H. And then we see that it has oxygen in it. This is an oxyacid. If I cover up the hydrogen, I've got NO3. NO3, put the charge on it, that's the nitrate ion. That's an oxyanion. H2SO3, also an oxyacid. Starts with H, and it's got oxygen in it. Cover up the hydrogens. SO3 is sulfite ion. So all the oxyacids are hydrogen ions attached to an oxyanion. The names of the acids come from the names of the oxyanions. And the number of hydrogen ions depends on the charge on that oxyanion. So sulfite and sulfate both have 2- charges, and that's why it's H2SO3 and H2SO4. Nitrate has a -1 charge. We only need one hydrogen ion, H+, to balance the charge. So the pattern for naming these, we take the name of the oxyanion and we change the ending. We do not use the hydro prefix. That's only for binary acids. So if the oxyanion name ends in "ite," like nitrite or sulfite or phosphite, then we change the ending to "us" and add the word acid. If the Oxyanion name ends in ate, we change it to ick. So here is a table from your textbook showing examples here. Notice the pattern with all of these acids. They all start with H, and they all have oxygen in them. These are all oxyacids. Let's look at this one. This one's kind of messy. HC2H3O2. There is a good reason that these three hydrogens are not grouped with that hydrogen. This is the hydrogen ion that comes off when this dissolves in water that makes it an acid. You don't need to know that, but I just don't want you to be puzzled. Why don't we write them all together? There's a reason. If we cover up the H, we have C2H3O2. That's a polyatomic ion that you should know the name of. That's acetate. We take the ending ate and change it to ick and add the word acid. So this is acetic acid. It comes from acetate, and there's the formula for the acetate ion. So if there's oxygen in the acid's formula, you need to look at the polyatomic oxyanion. No, I thought I had this somewhere on the, I don't. Okay, I have to tell you the silly sentence. I think it maybe shows up somewhere else, but I don't know where it went. So how do you remember the ick, ate, us thing? Oh, I know where it is. It's on the very last page, I think, of your worksheet. Rick ate him before he could bite us. That's a pretty silly sentence. The sillier, the better. So how's that going to help? Well, we have ite and us that belong together. Ite and us correspond. Ick and ate. So Rick ate. Ick, ate. If the anion ends in ate, you change the ending to ick. If the anion ends in ite, you change the ending to us. Rick ate him before he could bite us. Let's name these. So here's our formula, HNO2. We see it starts with H. This is an acid. And then we look and we see we have oxygen in it. This is an oxyacid. So cover up the H and write down the rest of it. So without the H, we have NO2. From the one H that's present, even if we don't remember the charge, we could figure it out. It's NO2 minus. We need to know the name of that ion. You're supposed to memorize nitrate, NO3 minus. Nitrite is the light version, one less oxygen. So this is the nitrite ion. And what do we change this ite ending to? Us. Rick ate him before he could bite us. So we changed nitrite to nitrous acid. And that's the name. Any questions? HClO4. Cover up the H. What's the name of that ion? ClO minus with whatever charge it's supposed to have. What's it related to? Chlorate? Chlorate is ClO3 minus. Why? Why is that chlorate? Because I said so. That's the best reason, right? It just is. That's what we decided to call it. That is chlorate. There's not really any reasoning there. We had to name it something, that's what we decided to name it. Well, when we add one oxygen, charge stays the same. This one has extra oxygen, like an extra energy in a child. We say they're hyperactive. They are more active. This is perchlorate ion. Okay, so that's the perchlorate ion. We're making an acid out of this. We look at the ending. What do we change ate to? Rick ate. change it to ick. Rick, ick, ate. Or you can think of eating something and saying ick. I ate it, it was icky. Perchloric acid. Any questions? It would be perchloric acid. Hydrochloric acid is HCl. If it has a hydro prefix, it's just hydrogen and one other element, no oxygen. It's a good question. So there's two different ways of naming acids. You have to get the right system. And you'll get some practice on the worksheet today.